Hey guys, optimization. So first of all, this is your homework for tonight. It's just this first one, not the second one, okay? So that page and then 1 through 11 odd. So you have what, like 6 problems for homework. You're going to try it out. All right, optimization. Actually, this is stuff that we already can do. We just haven't done it in this way before, okay? So optimization means like when you see the words the greatest or the least. So that's what we're looking for. We're answering that question is what is the greatest, what is the least, what is the most, what is the smallest, whatever, okay? Steps to solving problems. So the first one is you're going to draw a picture. So you're always going to draw a picture, if possible, or you're going to like label some things, okay? You'll see. And then number 2 is you're going to make an equation using one variable. So your equation is going to be like f of x equals or a of x equals, so like area, or it could be a perimeter equation, but you're going to use one variable, okay? And then number 3, you take the derivative of the optimization equation that you just made, and then you solve for 0. Why do you take a derivative? Because you're looking for the most and you're looking for the least. So basically when you take a derivative and then you set it equal to 0, that gives you a max or a min. Okay, the most and the least, that's a max and that's a min. All right, so that's what we're doing. And then finally, we actually answer the question. I know it seems silly, but you have to read the question again and make sure you answer the question. Okay, because a lot of times you'll just stop and be like, I'm done, I found X, I'm done. But you didn't answer the question. Okay, example 1. So you're fencing off some poisonous flowers along a river. The side along the river needs no fencing, so whatever for the fish. What is the greatest area we can fence off using 300 meters of fencing? So we've seen this kind of problem before, but we're doing it a different way, okay? So you saw it before in like algebra 2 and pre-calculus. All right, so first thing is we make a diagram. So here's my river, and then I don't need any fence along that. So then my fence is gonna look something like that, okay? So then I have 2 sides, and then I have a side that's parallel to the river. All right, I have 300 meters of fencing. I want the greatest area. I underline one of these words, either greatest or least or most or whatever. So it's going to have one of those words in it, some maximization word, max or min. And then it says greatest area. Okay, I want to make an area equation. And I want to use this picture with whatever information they give me. So I have 300 meters of fencing. So this whole thing is 300. If I call this x and I call this x, this is 300 minus 2x, right? If I add it all together, I get 300. So I have to make my own picture and label my picture using one variable, not x and y. I want to try to do one equation, okay? So my one equation in one variable is going to be an area equation. Area is length times width. So I'm going to do area equals x times that. All right, I'm going to multiply it out. And then I take the derivative. So step 3 is take a derivative. All right, no problem. I take a derivative. And then you solve. So set equal to 0, solve, x equals 75. So I'm going to check that 75 is indeed a greatest. I'm going to check that's a max. So then over here, I like plug in 1 into, let's say, here, and then I get a positive. I plug in 100 to here, and I get a negative. So yeah, from positive to negative, if you're going up and then down, that's a maximum. So I check it to make sure, because sometimes the question's kind of tricky, okay? So I make sure it's a max. And then I go, okay, I'm done. But then really, you gotta answer the question. So what is the greatest area? Oh, I got to find the area. So I use my area formula, I plug in 75, and then here's my greatest area. Okay, make sure I label my answer. Okay, and then it says, what is the smallest area? So some of these questions, you're gonna be like, well, if I do that whole thing again, I'm gonna get 75. That's not the smallest, it's obviously a max. So you're gonna use a little bit of logic. And be like, okay, the smallest area, if I were to redraw that, it'd be like that, right? So then you have this domain from 0 to 300. And then the smallest area, if it's like this, is going to be, well, you're not going to plug in 300. You're going to plug in 0, right? Or actually, if you plug in 300, you get this too. So if you plug in 300 into here, well, that doesn't make sense. You plug in 150 and 150, you're still going to get 0. So what is the least area? Sometimes you just have to think about it for a second. Oh, it's going to be 0. Okay, example 2. So I'm going to talk through it a little bit faster. I'm not going to show, all my work. You can see it, right? So I want the least. I underline that. And then the least fencing. So I box my fencing. That is a perimeter equation. So I put P of X. I always label what kind of equation I'm looking for, okay? I try to make it make sense, not just F of X for everything. And then you have this area. Okay, so number 1, you draw a picture. So same situation, you draw a picture. If this is X, then this has to be X. If this is your area, then what's going to be your length? Well, if this is the width, and you multiply the width and the length to get 80,000, then doesn't this have to be 80,000 divided by X? Because if I multiply it together, it has to be 80,000, right? So sometimes people like to do, W and L, and then kind of use this to solve for L. That's fine. Either way, you're going to end up with the same variable, okay, for all 3 sides or whatever you're doing. Okay, so again, I look back at this and I go, okay, I need perimeter. So the perimeter equation is going to be these 2 plus this. So 2x plus that. You find the derivative. You set it equal to 0. You solve for x. You check on a number line that it's actually a minimum, because that's what you want. You want a least. You want a minimum. And then since it is a minimum, then I go ahead and plug it in, and it says, what is the least amount of fencing? Plug it into my perimeter equation, and my least amount is 800. Okay, same thing here. So the only difference is this is talking about numbers. So find 2 numbers whose sum is 21 and product is the largest. A lot of times it's hard to tell what's what. You want largest, I underline that. You want a largest product. So I'm going to call that P, just because product is P. Okay, so largest product. I want 2 numbers. So here's my quote picture, okay? It's going to be my first number and call whatever I want. I'm going to call X. My second number, if the sum is 21, my second number has to be 21 minus X, okay? My product formula for any product is 2 things multiplied together. So my product formula is this. And then I multiply it out just to make life easier so that I could take the derivative. I set the derivative equal to 0. I solve for x. That is my maximum. I check it, and then that's a maximum. So if one number is 10.5, what's the other have to be? Well, the sum is 21, so the other one would also have to be 10.5. You can check your answer. You can multiply these together and be like, oh, that number is bigger than, and then you can try 1 times 20. 1 times 20 is 20. 10.5 times 10.5 is bigger than 20. It's 100 something. Okay? All right. Same thing here. So you want a sum as small as possible. I underline small. I box my sum. This is the formula I want. And then it says a number in the interval. I'm going to skip that for now. And it's a number and it's reciprocal. Okay, so the first number I call x. The second number is 1 over x because it's a reciprocal. And then I want the sum to be small. So I add them together. That's my formula for sum, adding together. I find my derivative. I set it equal to 0. I slowly work through it. I get 2 answers. I get a maximum here and I get a minimum here. So my smallest possible sum from -5 to 0, no, that's my largest possible sum, is to do -1 and the reciprocal of -1, which is -1. This is actually my smallest possible, but it's not on the right interval. So there's no such number in the interval -5 comma 0. That's why you want to check your answer. Because you're going to think like, oh, -1 and 1. Oh, my answer is -1. But no, -1 is not the smallest possible sum. Okay? All right. Last two. Here you go. I'm just going to show it to you. A largest area. Draw the picture. This is a hypotenuse. Here's your hypotenuse. If I call this x, I use the Pythagorean theorem to get that. And then the area is 1/2 base times height. 1/2 base times height is this. You can see, oh, I have to get my a prime. So it's going to take a little bit of work. It's going to be a product rule. So this times the derivative of this, and this times the derivative of this. So you can see my product rule, set it equal to 0. It takes a little bit of work, and I get root 50. Root 50, I check, is going to be a maximum. That's what I want. I want a largest area. So then I plug it in, and then I get 25 inches squared. Okay, so go backwards and rewind if you have to. Okay, the very last one. Find the dimensions of a rectangle with the smallest perimeter. I draw my rectangle. X. This has got to be 25 over x. Because if I multiply these, I should get 25, right? So my perimeter is this, and this, and this, and this. So 2x plus 50 over x. I take my derivative, set it equal to 0. I get x equals plus or minus 5, but that can't be -5. That doesn't make sense, okay, in the picture. So x equals 5. I check it. It is a minimum. I wanted a smallest, and it is a minimum. So then find the dimensions. My dimensions are 5 by 5. If that's 5, I plug in, and then I get 5. So there you go. All right. Good luck. I'll see you later.